Hello, I'm Carlyle Donevant with Equilibar, and today I'm going to talk to you about how to use an Equilibar back pressure regulator as a flow control device in a simulated inline conditioning system. The Equilibar back pressure regulator is used to control pressure upstream of the device by using a 1-to-1 pneumatically loaded set point on the dome of the regulator. A direct sealing diaphragm in the dome of the unit covers a field of orifices and adjusts its position to allow flow through the orifices to maintain a desired pressure set point. Using this relation, we can additionally control flow. In the system that we'll look at today, it utilizes two independent pressurized tanks that are set to roughly 1 bar. This common tank blanket pressure simulates individual storage tanks of concentrated stock solutions that may be used in an inline conditioning system. From these tanks, the fluid flows along its own independent process line through a high-accuracy flow meter upstream of an Equilibar FDO4 1/2 inch sanitary valve. Each of these FDO4 valves is set up in a control loop, with the flow transducer sending a signal to a PID controller. This PID controller monitors the flow from the flow transducer and checks it against a process set point. It then adjusts the signal to an electropneumatic valve, setting the pilot pressure to the Equilibar FDO4 based off of the process set point. The first FDO4 regulator is set to control at 10 milliliters per minute, while the second is set to control at 1,000 milliliters per minute. This really is intended to demonstrate that one single Equilibar valve can reliably reach a 100-to-1 turn down in flow control. The big benefit of this is it would allow a single buffer solution system to formulate a wide variety of solutions. Because you don't need a large volume of stock solution, you save on both cost and footprint. In the demonstration that we'll show today, at the outlet of the two valves, the lines are open to the atmosphere and dispensing into two different graduated cylinders. In an actual process, this would feed either a supply pump to a low-pressure liquid chromatography system or a dump valve that would be used for the settling time at the beginning of a buffer system production. So here is our setup in the lab. Just like the schematic here, we have two independent lines that are being supplied by head pressure-driven flow systems. In this case, we're supplying roughly 15 psi to our upstream side here. Downstream of that, we have two high accuracy kind of representative flow meters that might be seen in the field that are outputting their specific flow rate to a controller that is then interpreting the signal to a pneumatic set point to the BPR. For some additional information on how that works, feel free to take a look at our normal flow control how it works video. We can put a link below for some more information there. This pneumatic set point is then controlled to modulate your flow through the back pressure regulator. From the outlet of the back pressure regulator, it exhausts directly to atmosphere. In a typical inline conditioning system, like we stated earlier, this would feed a supply pump or your skid downstream. In this case, we're going to use two different volumetric containers, comparing these two identical back pressure regulators at a 100-to-1 flow turn down. So in one regulator, we're going to look for a 1,000 milliliters per minute flow rate, and then in the other back pressure regulator and flow control system, we're going to look for a 10 milliliters per minute flow rate. So we will go ahead and start the system up now. Equilibar valves can be used as flow control devices for high precision applications as shown like this inline conditioning or gradient elution process. In this demonstration, the Equilibar valve was set up in a flow control loop. The Equilibar can be set up with other transducers such as temperature, pH, or conductivity transducers as required by your process. For more information about this, feel free to reach out to us at equilibar.com and we'll be happy to help.